Assalamu alaikum. I hope you're doing well. So in this video, we will go over the remaining part of chapter 10, which we studied in week 6. The first half was covered in the class, and the second half will be covered in this video. So the topic that we are left with right now is types of media, which is nothing but types of cables or connections. You can even say connections because sometimes it is also wireless, which is also considered a connection. So you can either have wired connection or wireless connection. Either way, even if it's wired or wireless, there are certain things that can be accounted as the advantages or disadvantages for those connections. So some of them are mentioned here. Cable length can be an advantage or disadvantage. Some cables are only are not long enough. So maybe if you want to connect building floors in a building, you would want to use a certain type of cable which allows you to have the cable length that is required. Cost is another factor. Bandwidth is another factor. We know that fiber optic cables are more, I would say, are faster, have more bandwidth when compared to copper cables, from what I know. Ease of installation is another advantage or a disadvantage. Maybe, a cabling installation of a cable, of one type of cable could be easy when compared to, another cable. And whether or not they're susceptible to EMI or RFI, this is something we will look at later on. So what is attenuation? Cable length has its benefits and disadvantages. The benefit is that you can, connect maybe multiple floors on a building using a single cable, or that, the disadvantage for that could be attenuation, which is the reduction of the signal strength as it moves down the medium or the cable. This means you can picture this with something like, if you go to the top of a building or a terrace and you just shout something, you would see that at first you can hear it very, very loudly, but then, slowly you can hear that the sound is reduced, right? That's something that happens through a cable. At first, the signals are very strong, but as they move through the cable, they become slow and slow and slow, or less in strength. And that is what attenuation basically is. So the reduction of strength of a signal as it moves down the cable or the connection. If you have a longer cable, that means the attenuation will have more effect, and that's something that you need to take into account when you create connections or when you design networks. So cost is another factor. In perfect setting, fiber optic cabling would be very effective in connecting your devices on a LAN, and they provide greater bandwidth when you compare them with UTP, which is unshielded twisted pair cable. So these are the normal cables that we see. Maybe if you have been on the campus, you would have seen them connected to your machines. But fiber optic cables provide more bandwidth when you compare them with these normal cables, and the installation basically for fiber optic is very high. Not very high, but like higher than the installation of other cables. And so yeah, those factors also affect your selection of cabling or medium on your network. Maybe your client doesn't want to spend that much money, so they're okay with having an unshielded twisted pair cable that would have an effect on the bandwidth, but maybe because it's a small network, they don't really care about it. But maybe if it's a big network, if it's a big company, they're very particular about the performance, the bandwidth, and so maybe they would be willing to spend the money for the extra maintenance and installation of fiber optics. So again, that depends from client to client, organization to organization, but at the end, cost can also be a factor when you choose media for your network. Now, this is something I don't really think it is something you need to remember, but to know for information, it's good enough. So basically, the ease of cable installation. So basically, we have Cat5 UTP. There are many other categories, but then the one that is mentioned here is Cat5 cables, which look something like this. They're twisted pair cables, and the reason they are called twisted pair is because of how they're twisted here. If you can take a look, they have you're supposed to twist them that way, and once that is done, you need to put on this and once that's done, you would have this connector connected to it, so that you can plug it into different devices. And then these are some of the instruments you would use to instruments. I wouldn't say instruments. Some of the tools. Sorry, some of the tools that you would use to basically make that cable. Usually they're already made, but if you are, if you want to fix them or make them on your own as well, these are the tools you would use, plus the connector. And if you change the order of the connection, the cable actually changes. It becomes a different type. So the ordering matters as well in creating these cables. And then finally, you would test. You can use this device to basically test if the cable is working properly or not. Then there's optical fiber cable, which is nothing. It's made of tiny glass, tiny glass particles, and then you can use all of these connectors to basically connect them onto your network. Again, this is something you would want to know, but it's not something that you would want to remember. And these are the devices or tools that you can use to basically create and test fiber optic cables. Now, EMI and RFI, electromagnetic interference and radio frequency interference, must be taken into consideration when choosing a media type for a LAN. So when you're trying to pick a cable or pick a medium for your network, you need to make sure that the EMI and the RFI are not a problem, or their interference is reduced. So it's something like how when you get onto a plane, they ask you to turn off your mobile phones, just so that the signals would not interfere, right? So that's the whole purpose. Any electromagnetic interference should not happen, or it should be reduced greatly to have a good connection onto your network. Again, this has to do with electricity, power, cabling, all of those things. But just remember that EMI and RFI can have an effect on your medium that you choose for your network, and they can impact, data transfer on your network as well. This is something you need to know. Now, this is important for your exams. The others, not very much, but this part is extremely important. You need to remember when you are connecting different types of cables, different types of devices, you need to use the straight through cable. So I wouldn't really say different types of devices, I would say dissimilar devices, because you have a PC and then you have a laptop. They're different devices, but they are actually similar when we think about them, right? So with that perspective, you need to keep in mind that if you are connecting dissimilar devices, then you need to use straight through cable. And when you're using when you're connecting same type of devices, then you need to use a crossover cable. Now there's an exception here for PC to router and for switch to hub. In these two cases, you would use crossover. Okay, just remember it. From PC to router or vice versa, and from switch to hub or vice versa, you would use crossover cable. Every other connection is similar to this rule. So if you're connecting dissimilar devices, use straight through cable. If you're connecting devices of the same type, use crossover cable. The example for same type would be router to router, switch to switch, PC to PC, etc. Okay, so now we've done this in class, I think. But if you are connecting here, if you're connecting router to router, it's same type of device or it's similar. So this will be a crossover connection. A switch to router is basically dissimilar, so this will be straight through connection. Router to switch, again, this will be straight through connection. Here as well, between the switches, and these represent servers. So between the switches and the servers as well, you would have straight through because they're different or dissimilar. Between the switch and, now this is represented as a hub. So between a switch and a hub, it would be crossover like we mentioned before. And between a hub and a switch, you would have straight through because they are different. Okay. This is something that you should have done in the class. If you have not done it in the class, I have uploaded a video for it on YouTube. You can check that out and follow it if you need to understand how to do the activity. Now, making WAN connections. WAN connections are, if you remember WAN, it is wide area network. And this connection happens when you connect basically two routers together. Okay. Now your routers, they're essentially connected to the ISP, the Internet Service Provider, and usually the connection between those two are using the serial cable. All this means really is when you connect two routers together, so let's say this is router 1 and router 2, you should be using this line, the red line. You must have seen it in previous exercises, and they are connected using the serial ports. So on both the routers, you will use the serial port when you're connecting two routers together. Okay, and these are the cable types that you would be using. Okay. Again, this would make more sense if we were doing it in the physical room or the server room. But again, just remember the two routers, when you connect them, it's a WAN connection, which is represented by this particular line. And then you would use the serial ports for connecting both the routers together. Now, usually when you connect to a server, an internet service provider, you have a connection called the DCE connection. Okay. This DCE connection is actually from the ISP end. So this is at the end of the provider. So your ISP provider, your internet service provider, Batelco, Zain, STC, whichever one it is, this DCE connection is on their end. Okay, on your end, you have the DTE connection. Okay, what is the difference? Now, the DCE connection, it supplies the clocking time. And the DTE connection, it receives the clocking time. But now your next question should be, but wait, what is clocking time, right? So clocking time is nothing but, you can think of it this way. So it's the time that both the devices agree to talk in, so that when this device is talking, the one at the provider's end, your device should be listening. So it is just making sure that when are the two devices going to be talking and how are they going to talk. So if usually you remember everything that you send is actually converted to a bunch of ones and zeros, right, on the network. So if you kind of continuously keep receiving these bunch of numbers, it can be difficult to keep track of them, right? So what you do is you set a clocking time. You say, okay, this is the time we're talking and this is the time we stop talking, so that the other person who's receiving it can get it, or can receive it properly without hassling it. Just like when someone is dictating something to you, if they're telling you to write down something, you they say something and they stop so that you can write, and then they continue talking, and then you continue writing. If they if they keep on talking, it will be difficult for you to catch up. That's the same concept. So that's why we have clocking services, to make sure that the receiving end and the sending end, or the supplier and the receiver, both know when they need to talk and when they need to stop talking. Okay, so that's the basic idea. Now, WAN connections, this is just to represent that this side is the DCE cable and this side is the DTE cable. So this is basically the customer's end, and this is basically the supplier or the ISP end. Okay. What else? So, okay, now the interfaces on a device. The interfaces on a device are nothing but I would say, the ports on the devices that are available. We'll look at the ports on a router, on a Cisco router. There's a console port, and we've seen it in one of the activities that it is used to configure the router. So you would plug your device, your laptop or your PC, you'll plug it into this console port so that you can configure it. Okay. Once you're done configuring it, you can remove the cable and that's it. But at the time when you want to configure it, you need to put the cable into this port or into this interface. We actually call it interface. We don't call it ports, but just for your understanding. The auxiliary port. So the auxiliary port is used to basically get in the dial-in connection to the router. Basically, to configure the router, the console port allows you the terminal access, which is like the command prompt. So the terminal, terminal access, and this is basically the dial-in connection port. Okay, so this allows you to basically have the dial-in connection with the modems, and I think that's what you need to know about this. And then the Ethernet port is just when you want to connect the router to either the other network devices or to the hosts. So either the other network devices or to the hosts. When you want to connect it for communication purposes, you would use the Ethernet port. When you want to configure the router, you would use the console port. When you want to have the dial-in connection with a modem, you would use an auxiliary port. God knows how to pronounce that. And the serial port. The serial port is to connect routers together. So if you want to connect this router to another router, you would use the serial port. Okay. Typically, networking devices do not have their own display. This is what I said in the class as well. Your routers, your switches, your hubs, they don't have, I mean, we'll specifically talk about routers in this case, but they don't have any mouse or keyboard or monitor for you to actually configure them or have access to them. So how would you actually configure them without, a monitor or a keyboard? How would you type in the commands and stuff? So in that case, what we do is we plug in a cable into the console port. We plug the other end to our PC or laptop, and then we configure it from our laptop. Okay, that's using the the console port, and the computer basically runs the terminal emulator, which is known as the hyper terminal. Just remember this name. So in order to configure the router, when you plug it in the console, when you plug a PC and the other end in the console port of the router, the hyper terminal opens up, which is nothing but a black window. And you just type in the commands and configure the device. Okay. Now, this is how you would basically connect the network device to a PC. You need to use the rollover cable. The rollover cable is nothing but the console cable. If you use it, if you want to use it in the packet tracer, if you want to find the cable in the packet tracer, it's called console cable. It's not called rollover. Okay, so you just plug in the console cable to the device that you want to configure, and the other end should be with the PC or the laptop, and then you'll be able to configure it using the hyper terminal. This activity, again, you should have done it in class. If not, please watch the video that I've uploaded for the activities for week 6, and you can just follow it from there. Again, this is, how do I say it, important. Okay, it's a PDF file, and I've done this activity in the video as well. It is important. It is almost identical to how your exam is going to look like. So please, please, please practice it as many times as you can, because the more you practice it, the more errors you will find in repeating things. See, when we repeat things, we kind of make mistakes that we wouldn't make the first time. And when you make those mistakes, you'll know how to fix those mistakes. And the benefit is that if you make those mistakes in exams, at least you will know how to fix them, right? And I'm always there to answer your questions if you have any. So please, please practice this as many times as you can. I will repeat this. 85% of your course is practical on Packet Tracer. So if you were not familiar with Packet Tracer, I don't know how easy or difficult it will be for you to pass this course. So make sure you practice this. And again, the video is there on YouTube. Watch that if you want to follow along. Okay, choosing a switch. Now there are different types of switches. There's a kind of switch which has all the ports have one speed and the same type. So you can either plug in UTP or fiber in switches mostly, but there is a kind of switch which allows you same speeds on all the ports, and the type is also same. So all of these cable or the ports would allow UTP cabling. There's another one that has one type, so all of them will be UTP, but there are multiple speeds. So one of them can be 10 megabits per second. The other one is 100 megabits per second. That's, again, your choice, which one you want to choose. And then there's a third one which has different types, or let's say 2 types, but the speeds are multiple. So you can have 10 megabits on one of them, 100 megabits on another, 1 gigabits on another one. But in this case, all of these 3 are basically the UTP ports, and this one is basically the fiber port. So this switch kind of allows multiple types and multiple speeds, and the others allow one type, or the others allow one type or multiple speeds, or one type and same speeds. Okay, so it's up to you how and which one you want to choose when you pick switches for your network. So just enough for today. Mixture of speeds, that is what we talked about. Both UTP and fiber. Maybe there are cases where some of your connections are with fiber and the other are with unshielded twisted pair cables. So, maybe that that switch will fit, your requirement. Or maybe all the devices have UTP and you want different speeds. For one department, you want different speed, and for another department, you want different speed. So in that case, you would pick this kind of a switch. And if all of them should be the same in terms of speed and the type of the cabling, then you can pick this one. There's no name given for these, but then it's just to let you know that there can be different types of switches that you can choose from. So now there are 4 physical areas in a network. Okay, This is your telecommunication room. The first one is your telecommunication room, and this is nothing but like the one that you've seen in probably on campus, which is the server room. It has the racks with all the switches, routers, and paneling, all of that in one room. Okay, the next is basically the backbone cabling, which is maybe you have multiple telecommunication rooms, or maybe you want to connect to some other, some other place that has other devices, other network devices. So in that case, you would have a backbone cabling, which is connected to the other place that you want to connect the devices to. Then you have the horizontal cabling, which is it takes the cabling from the patch panel to connect it to the devices, the host or the end devices. Okay, and then there is patch cable, or basically the work area, which has the patch cables that allows you to connect your devices together. You would have seen this in your classrooms, that they're on the walls. You would have seen them, that there's a patch kind of a thing, and there's a cable coming out of it, which is then connected to your devices. So those are the four areas. You have telecommunications room, you have horizontal cabling, backbone cabling, and work area. Now, work area is where your users are, the devices that they want to use. That's where everything is. So basically, your lab would be considered as a work area because that's where all the hosts or all the end devices are placed. Then the straight through UTP to 2 meters. Usually, the cabling that is used in the work area is the straight through cable, which is an unshielded twisted pair cable, almost of 2 meters in length. And this is, again, you must have seen this in your labs. If not, if you've been on campus, you must have seen this in the labs. Now, the telecommunication rooms has, again, connections to hubs, switches, routers. All of these are placed in a rack, and then there are connections made to each of those devices. The next thing is sometimes also contains servers. Yes, there can be servers as well placed there, but usually now everything is on cloud, so we don't really have servers. But yes, if it is a big organization, they may have servers as well. Horizontal cabling, it's a permanent link. Again, this is usually 90 meters. You may not have seen this because these are actually hidden, or they're usually coming out from underground or from walls. But this is where your patch panel in the telecommunications room is basically connected to the work areas. And usually the wiring that is used there is 90 meters long. And the vertical cabling is for the backbone cabling, which can allow you to connect to servers placed in other rooms. Maybe it can allow you to connect to telecommunication rooms in other buildings, or to wide area networks or internet connections. And these generally require high bandwidth because of the kind of connections they have. So just remember the 4 physical areas: telecommunications room, horizontal cabling, backbone cabling, and work area. And remember that for horizontal, we use 90, as it was mentioned here, 90 meters. Okay, and this one is basically 2 meters. And here you have high bandwidth. That's it. That's the most that you need to know from here. Okay. Making LAN connections, devices use 1 or 2 types of UTP interfaces. So there are 2 types of UTP or unshielded twisted pair interfaces. The first one is MDI, and the second one is MDIX. MDI is nothing but the think of it this way: it's the Ethernet port usually that is there on the device, and it transmits the data using pins 1 and 2 on the cable, on the port, on the interface, and it receives it receives through pins 3 and 6. Okay. The next thing is to know that this is just the Ethernet port on the devices. You can see them on computers, on servers, on routers, all of them. We've seen them on routers as well now. So these are the normal Ethernet ports. MDIX, however, are present on hubs and switches, and they are basically what this port allows you, or what this interface allows you to do, is basically plug in or use the straight through cable between hubs and switches. So we looked at this before, that if you connect a switch with a hub, you would use a crossover cable because they are similar devices, right? Now, this port, MDIX interface or port, allows you to use a straight through cable between a switch and a hub, and it switches the transmission and receiving pins internally. So it figures out on its own, the device figures out on its own on which pins it should transmit and on which pins it should receive. And it changes based on the cable you plug in. So you can plug in crossover cable as well, but if you plug in the straight through cable between a hub and a switch, it will automatically internally switch the transmission and receiving pins to kind of make the cable work. Okay. Now, many devices will now automatically detect the cable type and configure the interfaces accordingly. This just means that no matter which cable you plug in, straight through or crossover, the interface or the port itself will figure out which cable this is, and it will internally switch the transmission and the receiving pins. Okay, so on which pins it should transmit and on which pins it should receive, it will automatically internally reconfigure that according to the cable that's plugged in. That is in the most devices, that is in the most cases for most devices, okay? But just remember, there's a MDI port, which is normal port on every device that you see, and then MDIX, which is the crossover version that allows you to use a straight through cable between hubs and switches, and it automatically switches the pins that will send and receive internally. Okay, just remember that. And that's it for this video. If you have any questions, let me know. I've covered the most important aspects of the chapter. Just remember the basic ideas. That is what you need to know when you implement them in Packet Tracer. Apart from that, I think the activity that I spoke about, that is the most important thing that you should do in this week, and in the activities for this week. Try to do that as many times as possible, and let me know if you have any questions. Thank you for watching.